Hello everybody. Let's try to understand about data warehouse. So we know about a lot of data warehouse. Nowadays the primary one is Snowflake. There's data warehouses like Synapse Analytics, I think, in Azure. Then we have in S3 also and GCP also. Now a data warehouse, the fundamental thing you need to understand to identify the difference between a data lake and a data warehouse is that when you put the data in a data warehouse, you need to define the structure, you need to define the columns, you need to define what kind of column types are, all this thing. But when you put the data in a data lake, you do not need to define all these things. So what is a data lake? It's S3 bucket, is ADLS, things like that. Again, I will tell, when you put the data into a data warehouse like Snowflake, you need to define the structure, you need to define its columns, types, and all those things. Now why is that important? Because you are going to run queries on top of that to build something useful, to get something useful. Maybe what was the sales last year in the month January, and why is it less this month? All this kind of thing you might be running. So basic thing you need to understand is the difference between a data warehouse and a data lake. Data warehouse is schema on write. You need to define the schema when you when you put the data into the data warehouse. Whereas the data lake house, you can put the data, you do not need to define this structure. When you read the data from a data lake, then only that is become schema on read. Then only you need to define the structure. Hope that makes sense. Hello everybody, I truly hope all of you are doing wonderful. Let's quickly understand about data lake. Now data lake is a storage services in all the cloud platform, whether it's Azure, we have Azure Data Lake Storage Services, ADLS. Yeah. Then we have blob services like S3. Now in a data lake, unlike data warehouses, we do not need to put a structured data. What I mean, we do not put to define a schema and all those things. Like when you are putting in a Snowflake, you need to define the schema, the structure of the data before you can load it on a Snowflake. This is what we call schema on write. Unlike in a data lake, you directly put the data, and when you need to read the data, then only you need to define the structure. For example, you can directly put CSV, JSON, Avro, all kind of file inside a data lake, and it will not ask you to first define the structure. It will simply take it. You can even put images and any random data. It's highly scalable, it's cheap comparative to data warehouses, but again, you cannot run query directly. You need to first define the structure. This is where the difference lies. Hi everybody, one basic question which is often asked in interviews is, what is our data pipeline? Now this is what ETL engineers build, right? They build a data pipeline. So data pipeline is a system in which we ingest data from different APIs, maybe on-premise, different multiple sources. And now in the way of data, think of it like a pipeline. It's getting ingested. In between, what happens? The transformation started happening. Some logic, some transformation, maybe PySpark, maybe other logic. Afterward, aggregation. So the cleaning, validation, everything done, aggregation and things like that happening. There is still the transformation step only. Now that the data is ready for maybe analytical purpose or maybe some other purpose, it's getting loaded into a cloud, Snowflake, ADLS, S3, multiple places. This is what a data pipeline is in a nutshell. There's more to it. A book can be written about a data pipeline, but in some simple terminology, at least you should be aware about these basics. Thank you so much. Hi everybody, hope all of you are doing absolutely wonderful. One question which is often asked in interview is, it's about OLTP systems. So OLTP, as the name suggests, it stands for online transaction processes. Now as the name suggests, you can imagine that whenever a transaction happens, a OLTP system triggers. Example table would be like customer table, transaction table, order table, all this kind of table. Now OLTP systems are highly normalized, meaning the tables are broken down into multiple tables. Why? To avoid data redundancy. When transactions happens, it's millions of row. Data redundancy, data volume becomes a major issue. And again, we need easy insert, update, delete. That is also one of the reasons. It's highly normalized. The tables are broken down into multiple tables. When you write a query, you typically have to write a very complicated query if you want to get something analytical. That's where OLAP system come into picture, which is OLAP, which is not normalized, which is like built to run faster queries and give insight. So the tables are denormalized, and most of the data, related data, comes into one table. Even though it causes data redundancy, you can still run faster query, and the stakeholders can run easy query and get all the insights. It's very useful for like dashboarding and things like that. Hope this clears a little bit of your doubt. Hi everybody, today let's quickly try to understand what is a delta table is. So a delta table can also be considered as a bulk table, which is built through a layer on top of data lake, which is basically a place where you store your data. Now a delta table give it ACID compliance. ACID means like atomicity, consistency, isolation, and durability. I hope you know those things, right? And now it also give it other features like time travel. So if you do something accidentally, if you accidentally edit or delete some rows, you can travel back into the time and get those rows again, which makes it very useful. It is available on a lot of platforms, for example like Databricks. Hope this video makes sense. Thank you so much.